brief calculus tutorial on uses of the derivative of a function and how it relates to the function. First, you need to know what the derivative of a function is. The derivative of a function at a particular point is essentially the slope of the line at that point, or the rate of change if you prefer. For practical purposes, let's consider the function f of x to represent the position of a particle in space. The derivative of that function, denoted as f prime of x, represents the rate of change of the position, or in simpler terms, the velocity. You can also take the derivative of the derivative, or the second derivative, denoted as f double prime of x. This represents the rate of change of the velocity function, or the acceleration. Now for the question. An X-15 aircraft is dropped from under the wing of a B-52 at an altitude of 13,700 meters. The plane essentially falls for about 8 seconds, at which point the airspeed increases enough for it to stay in the air on its own, and it starts a rapid climb to 82,000 meters, which takes about 2 minutes. The plane's altitude during this climb can be modeled by the piecewise function negative ln of x minus 1 plus 13,700 for x is less than 8, and 5.5 quantity x minus 8.02 squared plus 13,700 for x is greater than 8. A. What altitude is the aircraft at when it begins to climb? B. How fast is the rate of climb increasing at that point? C. Once the aircraft reaches 82,000 meters, the engine runs out of fuel and it begins to descend into ballistic arc. What is the rate of climb at this point? The solution sounds complicated, but it's actually pretty simple. The first part of the question, when the aircraft begins to climb, can also be looked at as asking for the point when it stops descending. At that instant, the rate of change in the aircraft's altitude is 0. Recall that the derivative represents the rate of change of a function. Taking the derivative of this function yields negative 2 over x minus 1 for x is less than 8, and 11x minus 8.22 for x is greater than 8. This is a more complicated process that you will learn how to do in calculus, but for now I just want you to focus on how the function's derivative and second derivative relate to each other. Now that we have the derivative, we can do a little bit of algebra to determine where it is equal to 0. This turns out to be at 8.02 seconds, so that's our answer. Part B asks for how fast the rate of climb is increasing 8.02 seconds into the flight. In mathematical terms, this is just the rate of change of the rate of climb. Sound familiar? Well, it should, because that's just the derivative again. Taking the derivative again yields negative 2 over x minus 1 squared for x is less than 8, and 11 for x is greater than or equal to 8. From this, we can see that the rate of climb is increasing at 11 meters per second 8.02 seconds into the flight. Now let's pause for a moment and look at this in the context of the original question. To find the rate of climb, we took the derivative of the function for the altitude. To find out how quickly the rate of climb is changing, we took the derivative of that, or the second derivative of the altitude function. The second derivative is the same as acceleration. Therefore, we have learned that after 8 seconds, the aircraft is accelerating at a constant 11 meters per second, which is about 1.2 Gs, if anyone was wondering. Part C asks for the rate of climb when the aircraft reaches 82,000 meters. Remember what we just said about the rate of climb being the derivative, which we already found? We just need the time when the aircraft reaches 82,000 meters. Some basic algebra with the altitude function tells us that this happens at 114 seconds after launch. Plugging this value into the derivative that we found earlier shows that, at this time, the aircraft is climbing at 1,166.7 meters per second. That's really fast. As usual, I'll leave you with some amusing facts. The B-52 that launched most of the X-15 flights was named Balls 8. Seriously? What were they thinking? Second, the X-15 has no rear landing gear. Instead, it has a pair of metal skids with no brakes. This means that the rollout after landing was extremely long, as you can see here.